Well, thank you very much, Lance. And we'll both be doing this talk today as a tag team, David and myself. We work together quite closely in terms of uh, looking at the kind of challenges that our customers are facing and how we shape our solutions. David a little bit more on the IP side, myself more on the optical side, which really come together in terms of shaping the intelligent middle mile. So I think it's appropriate that we both do this together. David, if you want to say hello.
Hello, yes, and welcome everybody. And so, Jonathan, this intelligent middle mile, as we're presenting today, um, why are we discussing it? Why is it important?
Well, I'm glad you asked, David. If you Google middle mile, I think one of the things that you'll see is getting a huge number of hits. This is something that I just did sort of as we were putting this presentation together in terms of really who's talking about the middle mile. And it seems everyone's talking about the middle mile today. Not just companies like ourselves from a solutions perspective, but many industry participants, both on the standard side as well as on the customer side, the industry analyst side. This seems to be popping up all over the place. So, probably from a few years ago, where middle mile was more of a niche term, I think one of the things that we're seeing recently is that it's really worked its way into the front of our industry's mindset that people more and more are talking about the middle mile. And I think this is probably a good time to ask ourselves, well, what is the middle mile? And David, maybe you can talk about that.
Yes, I can, and I agree with you about all the people talking about it. I've even seen people on LinkedIn calling themselves middle mile consultants as their job title. So, absolutely. So, what is this middle mile? Well, over the last 5, 6, 7 years, we've had a lot of money, investment, time. All the talk has been about the last mile or the access network. Fiber rollout, massive investment from government initiatives to get that fiber rollout done, and also 5G new radio rollout. So a lot of talk about the last mile and the access network, and a lot of talk about web services and new applications. But to tie this new capacity, this new access network to those applications, you need a middle mile. So the middle mile is actually a very, very simple concept. It links the access networks to the new applications and services.
And of
And
course, this is longer than a mile, right?
oh yes, absolutely. It can span from a few tens of kilometers all the way to thousands of kilometers. And it can move with time because some of these core services and applications, Azure, Amazon Web Services, are now being distributed and moving along the middle mile. So it's no longer a fixed location. It can be anywhere along the route of the network.
Okay. Well, I think now that we've defined the middle mile, probably the next thing we should be talking about is what are how are our customers, how is the industry talking about the middle mile? And I think one of the things that sort of struck me that it really appears in many different forms across our industry. Because really, when you start taking a look at our networks, whether you're a service provider or, say, a large private network provider, such as critical infrastructure, you're implementing a middle mile network because ultimately what you're doing is you're connecting access resources like radio towers or fiber to the home or substation if you're a utility or railway stations if you're a rail transport provider and bringing this information back to data centers where the services are located. We see here a long list of these things. Any that you'd like to point out, David?
Well, I mean, I was going to agree with that. I mean, so anything that says mid haul, short haul, long haul, aggregation, backhaul, backbone, these are all words that's synonymous in the middle mile. So we see a massive focus on 5G XHaul at the moment. This is just a middle mile for the mobile with the cellular network. We still see a lot of focus on converged interconnect network SYN in cable. Again, it's just the middle mile linking the DOCSIS or the fiber that the cable codes have to their CCAP applications, and similar. And in critical infrastructures, with this mass rollout of industrial IoT and CCTV in the field area network and the new control centers that allow them to do real-time monitoring, that has to be connected. It's middle mile. So as you can see, the middle mile is the thing that makes the access network work. It gives the services the connectivity point to their end users.
So great. Now that we've established what the middle mile is from a functional point of view and from a geographical point of view, and we've also established that it really appears by many names by all the industry participants, I'd like to move our conversation into what are the requirements for the middle mile? What are the things that it needs to implement to do its job successfully? And probably above everything else, it needs to be service aware. Now, why does it need to be service aware? It's because it needs to be able to allow the people that have made the investments in the last mile networks, in the access networks, who have created all this kind of capacity going towards the end user, enable them to monetize that broadband. And in terms of monetizing that broadband, it obviously needs to support services. And not all services are cut for the same cloth. We're going to move to another slide in a minute, which goes to show how different services have different requirements to really drive this point home. But for now, take it on faith. There are differentiated services, whether you just have basic internet or work at home or gaming, etc. And the middle mile needs to be able to support these different services and the service level agreements that these services require. Not only does it need to be service aware, it needs to have a flexible topology. One of the things you pointed out, David, before was how our core is not really just a centralized physical core. It's a distributed core. So as a result of that, the middle mile needs to be able to cater to the core wherever it takes place. As well, different operators, if you're in the public sector, the private sector, different types of different customer bases, you have a different way and different biases for how you want to construct your network. So the middle mile needs to be flexible. It's not going to all have sort of one cut of cloth that fits everyone.
I mean, I would add to that, Jonathan. It needs to be dynamically flexible as well, because as applications disaggregate and move closer to the access network, that can be, in the same network. You can do the thing like content delivery networks. You could decide to move a content delivery network closer to the edge. The network must follow the service, and it must follow the service dynamically. You do not want to have to rebuild a brand new network just because you've decided to distribute your core and your service in the center. So it's flexible, but dynamically flexible as well.
Okay. You want to talk about those last few requirements briefly?
Absolutely. So the other thing we're hearing a lot from operators is it's increasingly difficult to forecast how the network will grow, where extra capacity, extra types of services will be. And that's causing them a real big headache. So either they have two choices at the moment. Either they can completely over-provision their network and put too much capacity in too many places, or they can miss out on customer opportunities because they don't have capacity in the right places. The whole idea of an intelligent or a middle mile, it needs to help solve that problem by allowing the network resources themselves to be allocated to wherever they're required. So as demands increase in one part of the network, you can allocate the capacity and the network functions to serve those capabilities. Then in an ideal world, you could use machine learning, etc., to learn how the network is evolving, what's growing, and make predictions in advance of time as to where you need to add new network resources. So forecast tolerance is really, really important in the middle mile. Then finally, of course, you want to make sure that your middle mile is cost effective, so you actually make money. It would be very easy, would be the wrong word. You could build a middle mile network which had the lowest possible latency, the highest possible availability, and absolutely huge capacity. You could build it, but you would lose an unbelievable amount of money. So the aim with the middle mile is it needs to use the service awareness, flexible topology, the ability to be forecast tolerant, but actually drive down costs so you use the most optimal IP and optical network resources to provide the capabilities that you need. So the aim of the middle mile is to minimize that TCO.
Yeah. Well, that's a nice summary of the requirements that we see for the middle mile. Now, I can give you an argument, David. Well, actually, before we get into how we build a middle mile, let's just spend 1 second on here. I think this is a nice diagram that you put together. I think you call this a rose diagram.
It is. It's what I call a rose diagram. It's in other worlds, it's used to monitor, show wind speeds. So the rose diagram, when you look at it, is for wind speed, but it fits this really, really well. And as you can see from the various colors, we've got 6 different types of service here. And, you know, if you look at, say, the business and enterprise service, the gaming, the streaming services, and the mission critical services, they all just seem to put similar top level stress on the network. But when you look in a bit more detail at that, the mission critical service, high speed isn't really massively important. You don't need a massive high speed network for mission critical. A lot of it is IEDs, sending one or actuators, very, very low speed interfaces. But you do need, in the mission critical network, it needs to be 5, if not 6 nines available, and it needs to have incredibly low latency. Whereas in high res streaming, there seems to be a similar weighted level. Speed is clearly the differentiator, and a high res, you know, if you're making money out of a high res streaming service, speeds are absolutely essential. Availability is important, but it's not, you know, it's not mission critical type stuff. And latency, again, when you're streaming, you need a good low latency in your network. There's a lot of buffering that's put on the receiving devices. So again, important but not key.
So I think this really drives home the fact that your middle mile network, to support all these different types of services, which ultimately it does, needs to be service aware to provide different types of capabilities and different transport performance to support all of these simultaneously. So let's see how this maps into some different architectures. So I think the easiest architecture for people that are sort of want to take a very basic approach is what we call the raw bandwidth approach. And this is primarily just optical backhaul from your ONT, say serving your access networks, all the way to your core routers serving the services over there. It's attractive to think about doing this because it's extremely simple in terms of just putting some optical fiber out there. However, by doing this, you have absolutely no service awareness taking place because there's no routing capabilities in this network to deal with the different types of services. So it absolutely does not support differentiated services and SLAs. And the only way that this kind of approach can come close to serving the different levels of service agreements for the different types of services is to massively overbuild and over-provision, sort of creating almost a common denominator for the most demanding kinds of services. And even then, maybe what you're doing is providing a slightly better best effort approach, but you're still not providing the guarantees that can come along with the services that your customers would be demanding.
And in addition, doesn't give you the dynamicity, if that's a word, that I mentioned earlier about as your topology changes over time, or your service demand changes over time. So, you know, the forecast tolerant thing I mentioned. If your service mix and service profile or your topologies migrate from the core to the end, it doesn't give you the flexibility to evolve with it. So in reality, you'd have to deploy either as services migrated towards the edge, you would have to deploy ROADMs in here in addition, or if you needed new capacity or new service points, you have to deploy new endpoints. And if the capacity grows above whatever your backbone link you've plugged into your ONT is, you have to do a forklift upgrade to upgrade. So in reality, whilst this looks, and people will tell you this looks like the lowest cost or lowest initial CapEx.
Well, it does probably have lowest initial CapEx. Initial at least, right?
Yeah, but as the network evolves over time, it gives you 0 degrees of freedom to evolve.
Yeah, so this approach, I would say, looks attractive on the surface, but sort of when you dig deep, and particularly if you want to provide monetization for your service, is not the way to go. So what shall we do about this? Let's take a look.
So that's interesting. So, I mean, I would say this is interesting because what you've done here is actually made the network more complex on the surface.
Well, we have made it more complex, but I think one of the things that you get from this complexity by adding an IP routing and packet layer over the optical network is you're adding degrees of freedom, and you're also adding services intelligence that could be associated with the classes of services and quality of services associated with that, running this over an IP network. So right away, you've solved, at least in terms of the inherent capabilities of the network, a service-aware capability.
And that then knocks onto the topology and the forecast tolerance and the economics, actually, because that IP layer is aggregating your services near the end user, allowing you to take mix low rate interfaces with high speed interfaces, and optimally aggregating the traffic together in a way that meets the SLAs. It can then route that traffic across the network to where it needs to go with the right capacity. So it deals with being service aware. It deals with flexible topologies. And because it's routing traffic in that way, you can be forecast tolerant as well. So if a new bunch of services springs up in a new location, you can at least use that core bit of the network to route the traffic the right way to hit those. And interestingly, even though we say economical is not economical,
well, I think that's one of the things that sort of strikes me on this when we put this chart together. It's a flat out no that it's minimal TCO. I mean, we both agreed right at the beginning that this adds complexity to the solution.
It very much does. But if you compare it to the previous example, the ability to aggregate very low speed interfaces to put on a higher rate transport, like the higher rate optical transport, could then actually mean even initial capex, even though you're deploying a separate optical network, the initial capex costs may be similar.
They may be similar, but at the same time, you also have higher, I would say, operations costs because you're managing two networks over here, correct?
That's absolutely certain. And for most of us who deal with IP and optical people, you're dealing with two different paradigms, two different worlds that throw darts across the partition at each other. Yeah. So there is an operational issue there.
So I think we're on the way to solving the problems in terms of the middle mile networks with service-aware, flexible topology, and forecast tolerant. But we still need to go a step further on how do we solve the economics of this? And this, David, is where I'm going to say the anticipation must have been killing everyone on this call, is getting towards what we call the intelligent middle mile.
Yeah, I need my drum set now for the drum roll.
The drum roll. So if you take a look, there's really just two kinds of changes that take place, that need to take place to get to the intelligent middle mile. There's probably many smaller things that are there as well, but I'd say that there's two fundamental things. One is the integration, is the better marriage of the IP and optical layer.
So Jonathan, do you have a slide showing this?
A slide what? A slide showing
the intelligent middle mile.
This is our slide showing it right now.
Okay, it's not. Obviously, my network's not got an intelligent middle mile because it's not moved forward.
I don't know, Lance. You're the moderator on this call. Do you see it being displayed?
I see it being displayed, so it may just be something on your end, David.
Must be my end. I won't touch it. I won't touch it.
You won't touch it. So we have the slide showing the intelligent middle mile, David, and like I mentioned before, the first step is the integration of the IP and optical, and I'm not sure which comes first, but do you want to tell us how you would go about doing this integration?
Yeah, so what you need to do on the integration is in that routing layer, is that the routing layer needs to be aware of the underlying optical layer so it can route traffic where it fully understands both how the routers are connected and how the underlying optical connectivity is laid out. So in routing, you can have mesh networks and they sit on rings. You need to know that if you're going to optimally use the resources in your network. Now, that photonic layer can either be a full-blown optical network, with optical ROADMs and OLS, or it can just be plugins. So what's called coherent optical routing, where you just put optical plugins into the routers and you do direct router connect. And part of the intelligence is for the system to help you understand what is the most cost-efficient mechanism to use to to achieve the service level performance you require. So many networks going forward, I think, will be a combination of a coherent optical routing and multiple layers where they're required.
Yeah, so I agree with you. It's finding a way to optimize the resources, giving you the flexibility of transport at the optical layer, as well as the service and routing flexibility at the packet layer, and really making sure that these work together in a sort of a very sympathetic marriage. But that's really not enough. And as I mentioned before, the other key ingredient is the automation and the way this is being run. And the automation and the intelligence, say, at the control layer takes place in many forms. It starts off with the planning of the network, of course, but then it really goes to the running of the network, both the dynamic allocation of resources to the network. We're moving to more centralized control planes that are taking place at the IP layer and could extend also to the optical layer today, but then also in terms of the automation of the operations of the network. So a lot of the tasks that could be, say, manual in the past, from provisioning the network to provisioning services, to doing analysis, to fault identification, doing restoration. More and more, we need to find ways to automate those to really remove the complexity from the network, remove the human beings from the day-to-day control of the network, and make these processes and operations automated, that we actually manage the complexity. We're extremely good. We've shown this in multiple other industries at managing complexity, from logistics, in terms of how things get shipped to you, down to the way your automobiles are run, to process control in sort of large manufacturing plants. The same thing could just as well apply to our telecommunications networks. So this is our vision for the intelligent middle mile. What we'd like to shift gears a little bit is to give you some idea about what we're doing about this at Ribbon right now. So I don't know, David, has it flipped for you yet, or are you still seeing the old screen?
I'm still seeing it, but don't worry about me. I know what we're talking about.
I know, because we've been through this. So in the terms of the Ribbon Intelligent Middle Mile, it's exactly like we've said before. We have three main product lines that we're bringing to the table. These are the pillars of our solution. Underlying the solution from a raw transport point of view is our Apollo optical networking product line. Then we have our NPT routers that work extremely closely with Apollo and also can handle coherent optics. And living on top of that, controlling the whole shebang, so to speak, is our Muse multi-domain SDN orchestrator. Putting these all together are the ingredients that we bring to the table for our middle mile.
So do you want to tell us more about this orchestrator? Because this is the intelligent bit, I think, or the main component of the intelligence within the intelligent middle mile.
Yeah, I'd like to talk a bit more about Muse, but just to sort of emphasize one or 2 points before that. Really, when you talk about an intelligent middle mile, it really needs to do two things. It needs to be effective and it needs to be efficient. The effectiveness ultimately is the service awareness, and we solve that primarily through the NPT layer and the various kinds of routing capabilities that it can provide, and David will talk about that. When you talk about the efficiency in achieving lowest TCO, that comes from the optimization, which again is the marriage of NPT and Apollo in a network, and the way we implement the automation and the overall network control using our Muse controller. So that gives me a good segue to move towards Muse. So Muse brings the intelligence and the automation to the middle mile. In the past, it was clear that the control layer, or the network management system, if you like, was there to support the network. The network provided most of the value. The network still provides, I'd say, the majority of the value, but the equation over time is shifting more and more towards the north, if you like, into the control layer itself. And while the sort of piping might take place within the network layer, the intelligence ultimately will take place in the control layer. And that's what we achieve through Muse. So this is a platform that we introduced a few years ago. It's cloud native by design, meant to live in the telco cloud. There's no hardware associated with it. You just install this as virtual machines. And it provides a number of key applications that provide the value that we're talking about. Probably the best place to start about this is the Network Planner. That's the fourth application down from the top. This is our tool. Today, it's still an offline tool, but it's getting more and more closely integrated with the real-time aspects. I mean, certainly it spits out the designs and then it works with this in terms of provisioning of the network itself. But it is a true multi-layer designer. It's not just implementing the IP, just not implementing the optical. It can actually do both of these together. It comes with a lot of sophisticated what-if tools that you can test the network design against different traffic patterns. You can test it against different failure mechanisms so that you can fine-tune it for the kinds of traffic capacities and availabilities that you expect your network to support. Working down the stack from there, the workhorse part of Muse is our network controller. This provides full lifecycle control in the network operations center, from provisioning of the network, provisioning of the services, and managing the network on an ongoing basis. It provides this through extremely intuitive screens, web UIs, and it does this in a multi-layer fashion that you see what's going on simultaneously, both at the IP and the optical layer. In terms of understanding what's going on in the network on a continuous basis is our Network Insights, which is continually gathering information from the network and creating all sorts of reports. And this could also link towards alarms or flag situations whereby actions need to take place, either to human operators or to automated processes. A lot of this can come from the Network Insights too. And then the third one is the Network Designer. And this is where I'm extremely proud of what Muse can provide. It enables, we've really gone in a very strong fashion towards the use of low-code tools. What we want to do is make automation, make customization simple. So in terms of designing services, there's a whole set of templates that you can start with, or actually build your templates from scratch, that you can support services with many configurations, layer 0 all the way up through layer 3. And then a really unique capability, and I personally, from what I've seen, I think we have the best implementation in the industry, is how we do workflow automation using low-code tools. So if you're a network operator, you can take any manual process, whether it's doing a provisioning process, whether it's doing a maintenance process, a debug process, a migration process. Think about the keystrokes that you'll put in. You can capture all these and start creating your own automated workflows sort of just in a natural way. So automation here isn't something which is replacing you. It's actually something which is augmenting your ability to perform your function within the NOC. And you can put in breakpoints anywhere in these automated processes that if you're still unsure and you want to have some kind of human intervention, you can stop it and say, give a check mark and let it continue.
I was going to say, Jonathan, I think that's really important for those of us who deal with or are IP on the IP side of the house, because we still see people just doing CLI in the IP side of the house. It's going to take an amount of time in those sort of operators to help you move your operation staff away from CLI to a command-driven network domain manager to a semi-automation and fully automation. So I think the ability that Muse does within this context is really helpful to develop the trust of the management system in helping you evolve where your IP staff are still CLI, to help them evolve through this process.
Okay, well, I think I've said enough about Muse for this brief presentation, but so let's go down to the sort of the service layer of the network, David. Tell us a little bit more about NPT service-aware routing.
Thank you, Jonathan. And as Jonathan mentioned earlier, that the whole point of the and purpose of the routing part of this network is to provide you that ability to aggregate the services and transport them in a service-aware fashion. And you know, we use a combination of industry standard and proven techniques to do traffic prioritization, diffserv, COS type tools on the buffer ingress and egress buffers, pretty standard, pretty common, and the various routing protocols that are associated with that. I know from IP MPLS, MPLS TP, segment routing, etc., across the network to make sure that you're following those paths. But what I think is, as I mentioned before, is really important in getting that service awareness correct, is not only do you marry the knowledge of the traffic prioritization, the routing protocols, is you actually understand what the real underlay network is. As I said, you might have a point-to-point, virtual point-to-point connection between two routers, which might span 2,000 kilometers and 14 road ends. You need to know that when you're doing the calculation. So really accurate path computation, which the automation system helps you do, is really, really essential when trying to guarantee your services and guarantee that you're going to have a lowest TCO. So then, having done this, you know you've got an aggregation network which can meet the performance correct parameters. You need to actually support all the various services that are being made available. So I've said, we can support all sorts of access networks which are going out there, whether that be 5G, cellular, fiber rollout, DOCSIS, etc. And also all the legacy stuff, because that's not all going away anytime soon. So you need a huge set of interfaces supported at your by your access aggregation boxes, and those can vary from very, very low speed, 1 gig, 10 gig SD8s on it, all the way through to probably 10 gig on the access side is probably where you're at. But then as you move further into the middle of the middle mile and towards the core, you're going to need to use 100 gig and even 400 gig direct coherent optics between those routers. So vast range of interfaces, vast range of speeds. Every network operator has their own favorite topology for how they build their network, whether that's chain, ring, mesh, partial mesh, spine leaf, or any combination of those. So your routing protocols, your routers are going to support, and ours do, all of the various topologies that are there. And similarly, every operator has their own belief and operational procedures around what sort of form factors are right for their part of the network. So what I mean by this is you might have, in a critical infrastructure, the need to have routing and aggregation which is available in a DIN rail format. It might be that it needs to be fully redundant. It might be actually all the redundancy is going to be done by the network, and you don't want to waste money on redundancy in your network element. So all the various form factors have to be supported. Again, this is all about TCO and making sure that you have the right fit form factor for your needs. So we've got these vast range of different capacities, interfaces, form factors that form this aggregation network. That could be very complicated to understand, manage. That's solved by every single router having an identical network operations software. So the whole portfolio that we offer has one single NOS that's been proven in mission critical type businesses, and also in big and small service provider type environments. And we'll touch on that later. Then finally, as we mentioned previously, we've got to integrate with the optical layer, because the optical layer is a key part of this. Whether that just be a ZR plus pluggable in the router to give you coherent routing, or whether that be connection to an OLS or an OTN with colored or even gray optics, it's essential that you provide that integration part into the photonic layer of the network. And Jonathan will touch more on that photonic part of the network.
Well, again, David, thank you very much about the IP layer. And let me just talk for a few minutes about what we're doing at the optical layer using our Apollo optical networking system, whose primary role in any middle mile network is to take those large aggregation, those large bundles of traffic, and provide the lowest cost per bit middle mile transport. One of the things that we've done with Apollo is really recognize that there's not a one solution fits all, particularly when it comes to transmission. And what we've done is adopted and made it easy for the customer to choose between two types of transmission optimization. One type is what we call capacity reached optimized. This is using the latest, highest performance transmission technology available on the market. We're just introducing now, it's already being deployed with some customers. It's what's called 5 nanometer, 140 gigabaud technology. What this enables you to do is to transport wavelengths up to 1.2 terabits per second. Or if you want to go a little bit below that, say 800G is a very sweet spot because it can support multiple 400 gigabit Ethernet interfaces, as well, of course, 100 gigabit Ethernet interfaces. And we can do this for over 1,000 kilometers. So previous generation of solutions supported 800G, but maybe only got a few hundred kilometers. We can easily do it to 1,000 kilometers. However, in some cases, you don't need all that extra power. You don't need all that extra bandwidth, but you're just looking, say, at a little bit shorter routes, say, for metro applications going up to 500 kilometers. And here we have available solutions that are power and cost optimized. Today, they support 400G, and then using the exact same form factor of plugins, you can upgrade that same solution to support 800G when these become available sometime next year. So by providing this kind of mix of capabilities, and of course you can run these together in your network, depending on different parts of the network, you need different kinds of solutions, you can really create an optimized optical transport solution. But providing an optical network is not just about providing transmission. You also need to be able to route these wavelengths through the network. You need to be aggregate these onto DWDM links. And over here, we have highly flexible wavelength routing capabilities through a very, very extensive set of ROADMs, supporting the full set of CDC capabilities with flexible grid. And in some cases, by the way, if you also want to do even more granular service level routing, you can augment your solution with OTN switching. We have a set of OTN switches running all the way from 400G all the way up to 16T that you can right size this through your network. Our Apollo solution's intelligent, it's self-reporting, it can be dynamically and centrally controlled, works extremely hand in glove with our Muse SDN controller. And then finally, recognizing that in some cases, we're putting parts of an optical solution together as say an overlay over someone's existing network, say running our transmission over someone else's OLS. We've tested with each one of our major competitors' OLSs, running all our different transmission schemes. So you can deploy this both in greenfield as well as brownfield environments. Extremely flexible, extremely powerful set of capabilities to provide the underlay for an intelligent middle mile. It's worthwhile at this phase switching gears, and we're getting towards sort of summarizing our main messages here, is I think one of the things that hopefully you've gotten from David and myself is that we live and breathe the middle mile. We consider Ribbon to be middle mile experts, and we've certainly proven this by multiple deployments for multiple types of middle miles that we've identified earlier in the presentation that you might be supporting within your network. Probably the most basic kind is just basic broadband backhaul and networking. David, this is something I know you like to talk about.
Yes, I do. And whilst it's, initially it is simple, where everybody's been used to best effort broadband, with the rollout of access capacity, the big fiber rollouts there, and people getting a gig to the home is not uncommon. I can have a gig to the home if I want it. That opens up the ability to offer a whole range of new services, which means the broadband backhaul network can no longer be just the raw bandwidth approach. For the reasons we mentioned before, we need to really support and do support the ability for our customers to grow as their service mix and service product portfolio grows. And the IP aggregation is absolutely key in those internet service providers to allow them to do it. But also, as Jonathan will say, that the optical backbone, as we said, for the reasons of TCO, absolutely key as well. And in this area, we also group in NRENs. Why is that, Jonathan?
Well, NRENs to me is just a particular kind of service provider, but they're a service provider for their own closed community, so to speak. So it's a sort of a quasi public-private network. They could be extending their service to anyone, but the architectures that they're adopting is extremely close to the kind of architectures that regular service providers are using, where they're actually running this over their own fiber, or in some cases dark fiber, but they're doing this over extremely large geographic areas. We have a lot of experience providing this to some of the largest NRENs in the world, such as Deutsche Telekom. Well, not Deutsche Telekom, I'm sorry. The German NREN, just as one example over here. But besides broadband backhaul and networking, we've put down 5G crosshaul. Do you see that as a special case over here?
Yeah, it's a special case in effect of the broadband backhaul. I mean, it's broadband backhaul for wireless. In the end services are very, very similar. But the fact is, connecting to a wireless network means we add some extra requirements on the need to do that. Front door has to be a certain very, very stringent capacity needs. Mass IoT or ultra low latency. Add extra requirements onto that middle mile network. Again, but with the service aware nature of the IP layer, that's just another set of parameters that we need to make sure we meet. And in fact, many of the guys doing broadband backhaul on the left are actually acting as wholesalers, offering broadband backhaul to mobile network operators as part of 5G XL. So in reality, you end up sort of combining those two boxes to get multi-service backhaul, multi-service XL.
Yeah, so we provide some of these backhaul and 5G, and particularly crosshaul, to some of the largest service providers in the world. Don't we do that?
Absolutely, and in all geographies, absolutely. So, yeah. And in some very, very harsh environments, in addition. So yeah, which is also where the form factors come in.
Yes, also quite demanding sometimes from an economic point of view. You have a category here which is interesting: TDM to IP migration. I'm not sure is that really middle mile?
Well, actually, it's a really interesting one because over the last few years, well, the last 25 years, there's been billions put into SDH and SONET in the network, and it is now reaching end of life. That networking technology, it's starting to fail. Most people who know how to provision, manage, maintain SDH SONET networks are retiring or looking to retire. So great, and now all the services have moved to IP. Why can't we just turn that network off? Well, unfortunately, there's a lot of high-value services still needing to be supported at a very low rate that are TDM, that are expecting SDH SONET. A lot of voice stuff, the old C20 and stuff like that, still in the network. And you need the ability to support those legacy services, but you don't want to keep the SDH SONET alive. So what you run is circuit emulation to allow at the edge of that access network, you put an aggregation device which converts TDM using CES into a packet transport technology, transport that across the network, de-encode it from the circuit emulation, and hand it off to whatever the service application is. So absolutely is typical middle mile, and it's an incredible amount of stuff that is required to do that. And we have unbelievable expertise and experience in doing this. It's amazing how much we do in this space.
Another area you have incredible expertise, and I'd say based on a company the size of Ribbon, because we are small and some of our competitors, probably an outsized portion of our middle mile deployments is what we call critical infrastructure, which you see at the bottom left. We have an enormously large track record with utilities and railway transportation in particular. Really anywhere, and it makes sense that they need a very strong middle mile infrastructure. These guys have huge rights of way spanning, in many cases, entire countries, and they need to serve their sort of end stations, whether it's a power station or a railway station. It could be hundreds of these being distributed through a country with a very reliable network that needs to support a mix of older technologies and interfaces within these endpoints and bring these all to sort of the most modern high computing data centers today. And this is something we excel at.
So, I mean, just to highlight that, in that field area network, some of the legacy stuff might be FXO, FSX, 64 kilobits, all the way through to streams coming out of high definition CCTV cameras used for security, environmental monitoring, at gigabit. So it's got to support all of those. You've got stuff that's controlling teleprotection or signaling that's unbelievably mission critical, really needs to be 6 nines available, through to a standard IT operation. So the ability to support the right protocol, so MPLS-TP for deterministic traffic, or IP-MPLS for the high-level traffic. And then huge distances along rail tracks, for example, the ability to integrate seamlessly with the optical layer and Apollo, I think, is fundamental for utilities, transportation, and defense.
Yep. Another category is high capacity interconnect. This one's a little bit of an anomaly because it's not really the classical middle mile of connecting access to the core. It's more or less connecting core to the core. But in many cases, you do need to interwork your data centers together. In some cases, this is across metropolitan areas where you really want to do this with the highest possible speeds, particularly when you're doing sort of asynchronous data replication. In other cases, you might want to do this where you're connecting things over large spans of water using submarine types of solution. And really what you're interested in here is extremely high reliability, high density optical solutions. And again, we have a lot of experience doing this from the short haul for getting to wavelengths with the technology you're introducing now up to 1.2 terabits per second, or doing this, say, in the other extreme for submarine applications where you're transporting this over many thousands of kilometers. And again, using our new technology, we can go 800G using submarine cable easily for several thousands of kilometers, maybe 4,000 kilometers. 400G, you can go across the Pacific. And then the final one, I don't know if I want to spend too much time, as I'd like to leave a little bit of time for questions, is converged interconnect network. And here what we're talking about is the same kind of middle mile solutions, but applied towards cable networks who have their own different kinds of access architectures. So again, like we talked about earlier, you need to have some kind of topology flexibility. Again, it applies in these networks as well. David, I think it's time to wrap up. And maybe
I agree.
There's some
I
questions
agree.
over here. So let's close with this slide over here. I hope some of the takeaways today is giving you on the audience a little bit better insights into why the middle mile is important, why the industry conversation is shifting towards the middle mile, and give you some clues about what are the requirements for this. And if you're interested in pursuing this more, why speaking to us in greater detail is not a bad idea. We can give you a solution which is service aware, it's secure. We purposely left security out of our presentation because it's this presentation in itself. But again, that's something we can cover in chapter and verse, spanning from user security to network security to infrastructure to application, and how this is interwoven into all our solutions, how our solutions are low-code automatable, forecast tolerant, and again, we can tailor something to you which is lowest TCO. If you want to learn more, you can contact us directly. We've given you our email addresses here, myself, Jonathan, and David. And we're going to be at NWC in a few weeks. And then at the end of March, we'll also be at OFC. And all these solutions will be available there. You can see how our network is running through some live demos that we're doing of our Muse SDN orchestration system actually running on a live network. And you can see how the network can be configured and monitored and managed. So we invite you to learn more. I mean, David, anything to add before we get to a few questions?
Well, other than, in addition to those two shows, we're also at MPLS World Congress, where we're showing how that technology, the routing technology, interworks in a multi-vendor environment in that middle mile. So feel free to join us at any of these events or any of the other events. We'll be showing our middle mile technology. It's not just slideware, it's real. You'll see the equipment. You'll see the Muse system showing you how the automation works. It's real and it's now.
Yeah. Lance, I'll hand it back to you. You've been sort of moderator, maybe gathering some questions from the audience over here.
Yeah, sure have. Thanks, Jonathan. Thanks, David. I just had a couple questions that came through, but I will say, while we're talking about these two particular questions, maybe, you still have time to put in additional questions. So scroll down below the slides and you can put your questions in there. So yeah, the first question came through about DWDM, and it is simply put, will IP over DWDM eventually replace a distinct optical transport layer?
So IP over DWDM is interesting. It's been talked about for over 20 years. I remember because we've been getting these questions on a lot of these kinds of calls, so I researched them a little bit, and people have been talking about replacing the optical layer for at least 20 years. I think for the first time, it has a potential to seriously cut into the optical layer, and it's actually doing that. We see this today, and the forecasts show that about 30% within a year or two of what classically would be handled by the optical layer will now be handled by IP over DWDM. But I think that's good. You're not going to fight technology. You're going to sort of follow the flow of technology where it leads you. And certainly these are a large part of our solutions. But I still think that for the foreseeable future, the next 5 years at least, maybe a bit beyond that, there's still going to be a very, very strong role for an independent optical layer. And you'll need both the solutions, building the coherence into the optics directly into the routing layer, and at the same time having a distinct optical layer. Look, a distinct optical layer gives you flexibility in terms of, it gives you different kinds of technology evolutions where you could use the much more expensive, higher power technology, say for the capacity reached optimized that I talked about before, where it's still way too big and power hungry to build these things into routers, so you can do aggregation and higher speed transport over an optical layer. It lets you do the old simple main argument against IP over DWDM of router bypass, or whereby you're just looking at certain kinds of routes where there's a lot of traffic, but they're not necessarily close to each other geographically, and then going through an intermediate router just doesn't make sense. Anything else, David? I know you're more the IP guy, so you like the IP over DWDM.
I do like the IP over WDM, but I don't want all the hassle of having to do all that power management that you do for more complex and longer links. And I think that has to be solved if you ever get rid of the optical layer, which I don't think you will, actually. I think what is fundamental is that there are horses for courses, and coherent routing, IP over WDM is absolutely the right solution in some spaces. Separate IP and optical layers is the right solution in others, and you need your intelligent automation system to help you plan the right network for you to allow you to achieve that. I mean, after all, a huge chunk of the optical network cost is in the transponder, and that's not going away anytime soon. It's either a transponder in the router or a transponder in the optical system. So,
okay. Yeah, so IP over DWDM, good. IP networks, also good. Anything else, Lance?
Yeah, another question came in. This is, sort of a broad topic. We hear a lot about it today across all different, sectors, certainly in our industry as well. But you haven't mentioned anything about AI. So what role do you think AI will play in intelligent middle mile, or just in general across the industry?
So we purposely didn't mention AI because we didn't want to make this a sort of a hype. There is absolutely no question that AI is going to play a critical role in the intelligent part of the intelligent middle mile. And when you start, I mentioned 5 years before, when you sort of roll out these networks 5 years from now, I can't even predict properly the extent to which AI is going to play a role, but I think it will be pervasive because these tools are coming on board, fast and furious. So we did talk about automation, how a lot of this stuff today can be handled in terms of converting from manual operations towards automated operations. But AI is going to work its way into every single aspect of the life cycle in terms of learning from the networks how to do better planning, learning from the networks in terms of traffic flows, how to do dynamic resource allocation and dynamic allocation of resources for services routing, how to do better service restoration when failures take place. These things are going to work their way incrementally into the network that we won't sort of recognize it going on 5 or 10 years from now. And these are things that we're starting to adopt within our own solutions. These are not things that we're just sort of ready to talk about and make announcements about sort of on a public forum like this. But if you do want to hear more about what we're doing, again, come visit us, and we'll talk to you and show you what we're doing at these trade shows.
I mean, I think, AI relies on data and information. It's not coming up with something magically out of thin air. It's all about information and data as the starting point. And all of our network equipment has the full telemetry information built into it. So we have the ability for the automation system, the AI system, to fully gather all the data it requires to start running those processes. I just thinking of going into talking to a Cisco certified engineer about why they should move from a CLI interface to an AI-driven automation. I think that might be harder to achieve than actually putting an AI system on the network. So this is not just a technology decision. This is an operational business procedures discussion as well.
Okay. Yeah, so there you go. AI will be there, and it'll be all over the place.
Yes, indeed it will. Well, thanks, Jonathan and David. I think we're about out of time today. I'm glad you put your emails here on the slide, so please take note of those 2 emails. If you think of some questions after today's webinar, feel free to email Jonathan or David. We will be getting a link to the replay today, the recording, as well as the PDF of the slides. We'll get those out to you sometime later this afternoon. You can always reply to that email too and ask your questions there. But we certainly appreciate your time. Please reach out to Ribbon, rbvn.com. There's plenty of content about the middle mile there, and plenty of ways to get a hold of us should you have additional questions. We look forward to seeing you at MWC if you're heading to Barcelona, or San Diego if you're heading to OFC, or some of the other events David mentioned. We'll be there. Come up to the booth, give us a few of your minutes, and we'd love to talk with you. Thanks so much again, and we will see you next time on the next webinar.
Thank you.
Thank you.